Hello everyone. So today we're going to go over section 0.4, factoring and simplifying of algebraic expressions. So here we have example number 1a, and we can see here that each term has a factor of x. So first we will factor x and write it in front of the expression. So we have x and then in parentheses 12x to the fourth power minus 19x squared minus 18. And here we're going to let y equals to x squared. And the purpose of doing that is to rewrite the second part of the expression as a quadratic expression. So we have instead 12y squared minus 19y minus 18. And here we're going to factor by grouping. So we are looking for two numbers, a and b, where the sum is negative 19, and the product will be 12 times negative 18, which is negative 216. Okay, so those two numbers will be negative 27. So we have here negative 27y, and then positive 8. So plus 8y. So the goal was to split up the middle term in the quadratic expression, as we have done here. Sorry about that. And now we can factor by grouping. So the first two terms have a greatest common factor of 3y, and that we're left with 4y minus 9. And the last two terms have a greatest common factor of 2. And again, we're left with 4y minus 9 there as well. So the idea here is both the first half and the second half of the expression now contains 4y minus 9. As such, it can be rewritten as 3y plus 2, and then the second part, which is 4y minus 9. Now, of course, our expression was originally in terms of x, so now we can substitute it back in. So we have 3x squared plus 2, and then 4x squared minus 9. And once we do that, it's important to note here that 4x squared minus 9 is a difference of squares, so it could be factored. So finally, we have x, the first term, and then in parentheses, we have 3x squared plus 2. And now the 4x squared minus 9 will be factored into 2x minus 3, and then 2x plus 3 multiplied together. And now the expression has been factored fully. Let's move on to example B. Again, a factoring question. So this one, the first step is to note that the first two terms have a greatest common factor of x, so we can factor that out. So we have, instead of xy plus 2x, we have x times y plus 2. And then the last two terms have a greatest common factor of negative 2y, so we can factor that out. Oh, sorry, negative 2z. And we are left with y plus 2 there as well. So very similar to the last example in this step here. Both the first term and the second term now contains a factor of y plus 2. So we can factor it there. And we're going to be left with x minus 2z times y plus 2. ahead and underline the common factor there. All right. Next one, we have example C. So this one, again, a little bit different. Now what we're going to do is consider the last three terms a little bit separately from the first one. So we're going to rewrite this as y squared minus, and then in parentheses, x squared minus 6x plus 9. And the idea here is that x squared minus 6x plus 9 is a perfect square trinomial. So it can be factored, and we get x minus 3 squared as a result. Consider that. Just going to go ahead and write it out here, that x minus 3 squared is equal to x minus 3 times x minus 3. And of course, we get x squared minus 6x plus 9 as a result, which is what we have on the left. So notice that now we have y squared minus, and then in parentheses, x minus 3 all squared. So that's actually a difference of squares. So sorry about that. So we can rewrite this as y minus x minus 3, and then y plus x minus 3. So we can almost treat the term x minus 3 as its own variable, and then factor that way. And afterwards, all we have to do is to simplify. So we have y minus x plus 3 in the first set of parentheses, and then in the second part we have x plus y, y plus x minus 3. Okay. So this was the second term in a difference of squares, the entirety of x minus 3. Okay, next one we have x to the 4th power plus 4. So here what we can do is we can complete the square. So we have x to the 4th power plus 4x squared plus 4. And then since we added this term 4x squared, we're going to subtract 4x squared as well. And now what happens is the first three terms, x to the 4th power plus 4x squared plus 4, is now a perfect square trinomial. And now we can factor that. So we'll get x squared plus 2 all squared, and then minus 4x squared. So now what happens is x squared plus 2 squared is a perfect square, and 4x squared is also a perfect square, so we can treat this expression as a difference of squares. So we'll get x squared plus 2 minus 2x, so the square root of both the first and second part of the expression from above, and then also x squared plus 2, and then plus 2x, since this is how we factor a difference of squares. So from here we're going to rearrange the terms and get rid of any of the parentheses that are no longer needed. So we have x squared minus 2x plus 2 in the first part, and then in the second part we have x squared plus 2x plus 2. And this cannot be further simplified, so we are done with this question. Okay, so let's move on to the next part. The next part is about sum and difference of cubes. So we're given this kind of equation here. And the idea here is that if we have, let's say, a cubed plus b cubed, then we use the signs from the top. If instead we have a cubed minus b cubed, then we use the signs in the bottom. Oops, sorry about that. Okay, so let's look at the first example. We have x to the 6th power minus 8y cubed. So both of these are perfect cubes. And we know that x to the 6th power is equal to x squared cubed. And that 8y cubed is equal to 2y all cubed, which means we can use the equation from above, which we will. So here instead then we have x squared minus 2y, right? So the x squared here is the a and the 2y is the b. And then afterwards in the second part we have x squared squared. And since this is a difference of cubes, we're going to use the red part of the equation. Oh, we already did that part. Plus, and then x squared times 2y is the middle term in the second set of parentheses, and then plus 2y all squared. And we're going to expand the second part of the expression, so the first part stays the same. And here we have x squared squared, which is x to the 4th power. The middle terms just get multiplied together, so we have 2x squared y. And then, of course, 2y all squared is 4y squared. And that's all that we can do to simplify the expression, or factor the expression. Okay, let's move on. Okay, so example B is a little bit different since it involves a cube root in the denominator. So first thing we're going to do is rewrite the cube root of x in the denominator as x to the negative, since it's in the denominator, and then to the 1/3 power, so negative 1/3 power because of the cube root. And then second part can pretty much stays the same. So this is still 2x to the 17/3 power. So here what we're going to do is factor out 2 and also x to the negative 1/3 power. And what happens is what's going to be left over is going to be 64, because 128 divided by 2. And then notice that the x term is just no longer there because we factored it out. And then the second part, the 2 is factored out. And then when we subtract 17/3 minus negative 1/3, we get 18/3, which is 6. So this actually is just x to the 6th power. Right, so just as a side here, we had 17/3 minus negative 1/3, and that's 18/3 over 3, which is 6. Okay, so notice that 64 is a perfect cube, and so is x to the 6th power. So very similar to the previous example, right? 4 cubed is 64, and x squared cubed is x to the 6th power. So again, we can use the equation above to expand this, or to simplify it, depending on how we look at the simplification of expressions. So here we have 4 minus x squared, and then we have 4 squared plus, this is 4 times x squared, and then plus x squared squared. Okay, let's go ahead and expand. So this would be 4 squared is 16. The middle term is 4x squared, and then we have x to the 4th power. Okay, so what is important to note here is that 4 minus x squared is difference of squares, so that could be factored. It's going to go ahead and continue over to the right. So we still have 2 and then x to the negative 1/3 power. So that's still in the front of the expression. Now the difference of squares will be 2 minus x, 2 plus x. And what's also important to note is that if we were to rearrange the terms in the last part of the expression, we actually have here x to the 4th power. Now we can add 4x squared. So the 4x squared becomes 8x squared plus 16. And of course, since we added 4x squared to the expression, we have to subtract 4x squared. So we'll do that. And the reason for doing that is because now we suddenly have x to the 4th power plus 8x squared plus 16. And this is actually a perfect square trinomial. So that means we have more to do. So this is 2x, and then to the negative 1/3 power, still that stays the same. 2 minus x, that stays the same. 2 plus x, that's still there. And now these three terms is a perfect square trinomial. We have x squared plus 4 all squared minus 4x squared. And what is important here, of course, is that this is now a difference of squares as well. So we can factor it. So the idea here is through a combination of expanding and simplifying, we are always factoring the expression. And the goal of factoring is to reduce the individual parts to a lower degree if possible. So here we can have x squared plus 4 minus 2x, and of course also x squared plus 4 plus 2x, and that's it for factoring. But we do want to write the terms in descending order if possible. So we have, as a final answer, something that looks like this. So x squared minus 2x plus 4. Okay, luckily for us, that can not be further simplified, and neither could x squared plus 2x plus 4. So we are done. And notice that we started with a term that is x to the 17 over 3 power, and then by the end we just have linear terms, so x here, here, and then also quadratic ones. So we have achieved the objective of factoring. Right? Again, that is to use a combination of expanding and simplifying algebraic expression to reduce the degree of individual parts. All right. And that's as complicated as a example really is going to get. The next one is a little bit simpler, but it does introduce the idea of rational expression and how we can use factoring to simplify them. So in this case, first thing we're going to do is just identify the restriction. So that is x cannot be 0, because otherwise we will be dividing by 0 here and also here. So once we establish that, what we're going to do is actually multiply both the numerator and denominator by x. So now we're going to get x squared, sorry, I forgot the equal sign, x squared plus 7x minus 8. And this will be over x squared plus 10x plus 16. So here what we can do is factor both the numerator and denominator. So the numerator factors to be x plus 8, x minus 1, sorry about that. And then the denominator would be x plus 8 and also x plus 2. So here we have a common factor of x plus 8. However, before we eliminate them, it is important to just state the restrictions that have been added. So also x cannot be negative 8 or negative 2. And we get to the simplest form of the expression, which is just x minus 1 over x plus 2. Sorry about that. But the idea here is that the restrictions that we added throughout are still there. So we still have x cannot be 0 from the start. It cannot be negative 8 just from above, and also it cannot be negative 2, even though the 0 and the negative 8 restrictions doesn't appear in the final answer, but they are still there. Okay, so that's it for today. We looked at fairly complicated factoring questions. Again, the idea is to reduce the degree of the individual parts through a combination of expanding and simplifying, and using the equation for sum and difference of cubes, and also factor by grouping and other techniques like that. And so that's it for today. Once again, thank you for listening.